Okay, welcome back. We're going to do a couple more examples here. In this example, I've got f of x is equal to x squared plus 4x plus 3. And remember, f of x is the same as y. So we've got y equals, and I'm just going to write, well, y equals ax squared plus bx plus c, so that we can see what a is. And a, since there's nothing in front of that x squared, we know that a is a equals 1. And so our direction of opening, since a equals 1, and 1 is greater than 0, 1 is positive, then this means it opens up. But we want to put this in factored form, and for that we have to factor this. So we're going to go up here and say, okay, AC, our AC value is 3, and our B value is 4. And since now we're looking for two numbers that multiply to AC that combine to give us B, and since AC is 3, it's prime, there's only two numbers that multiply to give you 3. They could both be negative, but since B is positive, they'll both be positive. So 1 times 3 is 3, and 1 plus 3 is 4. So these are the numbers that we're looking for, which is nice. That means we can write this as x plus 1 times x plus 3, using the numbers 1 and 3. All right, our vertex. So our vertex is x equals negative b over 2a, and b is 4. And so we're going to say negative 4 over 2a, and that's 2 times 1. And that's negative 4 over 2. And negative 4 over 2 is negative 2. I'm going to circle that. And over here I'm going to write vertex. The x-coordinate is negative 2. And then I want to find the y value. So y equals, and I'm using standard form, so x squared, which would be negative 2 squared, plus 4 times the x value, which again is negative 2, plus 3. And negative 2 squared is positive 4. 4 times negative 2 is minus 8. And then we have plus 3. And 4 minus 8 is negative 4. Negative 4 plus 3 would be negative 1. And so our y-coordinate then is negative 1. And we're going to put a box around this so we can see that's our vertex. And then I'm going to go to our graph and put in negative 2, comma, negative 1. So I go over to negative 2, down to negative 1, and make a point. That's our vertex. Since it opens up, I'm going to label it down below. So this is the point, negative 2, comma, negative 1. All right. Then move this over. Then the question asks, is it a maximum or a minimum point? Once again, to help us visualize this, we're going to just draw that it opens up, so it looks like that. And then you can see that the vertex nothing on the graph goes any lower than the vertex, and so it's a minimum. And we'll put a box around that again because that's one of our answers. Axis of symmetry is just the x-coordinate of the vertex. And so we say x equals -2. You do need to put that x equals because that denotes it as a line. So let's go over here to the line at -2, x equals -2, and we'll make a dotted line to show that's our axis of symmetry. Our zeros, for the zeros, we set y equal to 0, so I'm going to put 0 equals x plus 1 times x plus 3. And then I set each of those equal to 0. X plus 1 equals 0. Or x plus 3 equals 0. And then I subtract 1 from both sides. X then equals -1. Or subtract 3 from both sides. X then is equal to -3. And so our two zeros, or our two x-intercepts, are -1, comma 0, or -3, comma 0. And those are important. That's where it crosses the x-axis. So we're going to go up here and graph them. -1, comma 0 is right here. And -3, comma 0 is right there. And notice that they are 1 unit each from the axis of symmetry. So that helps us to know, hey, we did this right. And let's see, then our y-intercept. For our y-intercept, we're going to take the standard form that we were given at the beginning, f of x equals x squared plus 4x equals 3, and we're going to put in x equals 0. That cancels the first two terms, leaving 0, comma 3 is just the I'm not sure how that line got there. Let's see. That's just the c value, which is 3. That's the y equals 3. So 0, 3 is where this crosses the y-axis. So we go up here to 3, and we can graph a point. And then I see, hey, that's just 2 units away from the axis of symmetry. So I can go over another 2 units and graph another point on the left-hand side. And then I can sort of see what this looks like. So I'm going to start graphing that. And then I'm going to graph it on the other side. And see how that goes up. And then again, remember the little arrows, because these continue on up. They don't stop there just because that's what we're showing on our graph. Ooh, I forgot to put a box around our y-intercept. Let's do that. And then the domain. Our domain is all real numbers. And this time I'm just going to use our symbol R, which this is the set of real numbers. So every real number will work in this graph. The range. For our range, we notice that it goes down as low as -1. So we're going to put y is greater than or equal to -1. Or we can also write that as its lowest value is -1, and it goes up to positive infinity. And those would be our range of y values. All right, let's look at the third and final example. F of x equals -2 times x squared plus 12x minus 16. So I look at that and it's got that -2 in front. So the first thing I'm going to do is actually factor out y equals -2, because -2 and 12 and 16 all have a 2 in common. I'm going to factor out the negative, so our leading coefficient for the inside part will be positive. So -2 times x squared would give us -2x squared. The 12x becomes negative, so this is negative 6x. Negative 2 times negative 6x becomes positive 12x. So I'm just sort of working backwards along the way. And then negative 16, that would be plus 8. Because negative 2 times a positive 8 is negative 16. And so I factored that out. That sort of helps me to see that A equals negative 2. And so the direction of the opening, negative 2 is less than 0. So it opens down. All right, our factored form. Well, for that, we need to factor this. I'm going to come over and use waiting for this to focus here. I'm going to use my margins. So I say AC. My AC is and this time I'm only factoring what I've got inside the parentheses. I factored out the negative 2, so now I'm just working on x squared minus 6x plus 8. So A is 1 now, and C is 8, so AC is 8. And B is negative 6. So I'm looking for two numbers that multiply to 8 that combine to negative 6. And since 8 is positive, that either means that both factors will be positive, or both factors will be negative. And since B is negative, that means both factors will be negative. So I'm going to put negative 1 times negative 8 to see if that works. Negative 1 times negative 8 is positive 8, but negative 1 plus negative 8 is negative 9. So those are not the numbers we're looking for. So then I go to negative 2 times negative 4. And those multiply to positive 8, but they add. Negative 2 plus negative 4 is negative 6. And so those are the numbers that we're looking for. And so then I can write this factored form. The A that we factored out in front, negative 2, is still there, times x minus 2. That's the first factor. And then our second factor, x minus 4. And let's see. That's going to help us when we get the x-intercepts. So vertex, we say x equals negative b over 2a, and we'll write it every time so you remember. Negative b over 2a. And b is 12, so it's negative 12. Now I'm going back to my original standard form equation that I had here for b and a. Negative 12 over 2 times a, and a is negative 2. So that's negative 12 over 2 times negative 2 is negative 4. And I've got a negative divided by a negative, which is positive, and 12 divided by 4 is 3. So here, once again, I'm going to write vertex, and my x-coordinate is 3. And for my y value, I'm going to put y equals negative 2 times the value we just found, 3 squared, plus 12 times the value 3 minus 16. And this gives us negative 2 times 9 plus 12 times 3, and 12 times 3 is 36 minus 16. And negative 2 times 9 is negative 18 plus 36 minus 16. And do a little number crunching here. Just plug it into your calculator if you want. And that would give you 2. And so the y-coordinate of our vertex is 2. And let's go ahead and put that put that in here. So 3 comma 2, we go over 3 in x and up to 2 in y. And that gives us our vertex. It opens down, so I'm going to put up above it just to label it. This is the point 3 comma 2. And our, let's see, is it a maximum or minimum point? Since it opens down, it's going to be a point that is the highest point, so it's a maximum. And then the axis of symmetry, remember, is just the x equal the x coordinate of our vertex, which is 3, so it's x equals 3. Let's bring that over to our graph and also mark that in just as a dotted line. It's pretty faint, but we get the idea. Zeros are the x-intercepts. So we've got our factored form. We put 0 equal to -2 times x minus 2 times x minus 4. And remember, with the zero product property, our factors have to be equal to 0. And -2 cannot be equal to 0, so we're going to forget about that one while we're solving these. So I got x minus 2 is equal to 0, or x minus 4 is equal to 0. So here I add 2 to both sides, and x equals 2. And here I add 4 to both sides, and so x equals 4. And so our zeros, or our x-intercepts, are 2 comma 0 and 4 comma 0. So let's go ahead and write those in our graph, or graph them, I should say. 2, 0, and 4, 0. There's 2, 0, and here's 4, 0. And it's nice again because we see that they're equal distance on both sides of the axis of symmetry, which is what we would expect. All right, our y-intercept. For our y-intercept, we're going to go to our original equation in standard form. And it was -2x squared plus 12x minus 16. When you put in zeros for the first two terms, they just zero out, and so you're left with 0 comma -16. Now that's completely off of our graph. Our lowest point on our graph is at -6, so we're not going to be able to see it, but at least we have an idea of where it's going. And then our domain, as with all of our quadratic equations, quadratic functions, is all real numbers. And then our range, let's graph this and then we'll come back to this. So I want to know what happens at 1. So I can see what happens at 3, at 2, at 4, but now I want to know what happens at 1. So I'm going to say y equals -2 times 1 squared, and I'm just using my the original standard form equation, plus 12 times 1 minus 16. And 1 squared is just 1 times 1 times -2 leaves us with -2. 12 times 1 is 12, and then I have minus 16. And -2 plus 12 is 10, and 10 minus 16 would be -6. And so at 1, we're down here at -6. And the nice thing about that is, since we found 1, we can just go over and say, hey, this is 2 units from our axis of symmetry, so I can go over 2 units to the other side and plot another point. And you could verify that 5 in there in the original quadratic equation, the standard form. If you multiply it out, you would also get -6. So now we can graph this, making it a curve. Take your time, be neat. And then remember the arrows to show that this continues on downwards. And here we see that for our range, the highest point is at 2, and it goes downwards. So we have y is less than or equal to 2. And in interval notation, that comes out to be, need to move me out of the way, that comes out to be from -infinity, which is the lowest value, it just goes all the way down, comes up to 2 and includes 2, so we're using a bracket instead of a parenthesis. And then we can put a box around that to show our answers. And that is our final example. Thanks for watching.